So can you see this? Can you see this slide?
Yes, sir.
Okay. See, so yesterday we have stopped here, the Terzaghi's bearing capacity theory and Terzaghi's bearing capacity equation. So what we have said that the equilibrium condition of this wedge is being considered, and considering this equilibrium of the wedge, Terzaghi has come to a formulation or an equation which is nothing but this one. Final equation of bearing capacity is this one, that QU is equal to CNC plus QNQ plus 0.5 gamma B N gamma. Okay, so you see this is actually the equation for ultimate bearing capacity, considering a foundation or a footing is a shallow footing or shallow foundation, and the base of the footing is rough. Okay, and where the footing is standing, the footing is standing at a depth d below the ground surface. So you see, in the previous class we have discussed this diagram. So footing, the depth of the foundation is df. Okay, so the depth of the foundation when it is df, so what is the value actually, what is this equation is actually saying? What is this C? C is nothing but the cohesion of soil. So C is the value which is having unit, the cohesive strength of soil. The cohesive strength of soil is having unit like kilonewton per meter square. Then there is a factor, you see, there is a factor called Q. So what is this Q? Q is nothing but the surcharge weight or the overburden pressure. So Q is nothing but, if you see from this diagram, yesterday we have discussed it. See Q, you can see this factor Q. Q is nothing but the effective overburden, that is nothing but gamma into df. So Q you can replace in this equation by gamma df. So sometimes you will see this equation is written like Q is equal to CNC plus gamma d NQ plus 0.5 gamma B N gamma. Just to keep a symmetry, here instead of Q you can also write in the equation it is gamma into D, because Q is nothing but gamma D, right? Gamma into D. So are you getting this point? What is Q? Is there any confusion about this Q? Okay, so you see the ultimate bearing capacity equation, thus you must remember this equation. Either you remember CNC plus QNQ plus 0.5 gamma B N gamma, or you can remember CNC plus Q, you can replace with gamma D NQ plus 0.5 gamma B N gamma. Now you see this Q we have explained. Now what is this gamma? Gamma is the unit weight of soil. And what is B? B is the width of the footing. You have seen this. This is your B. This is the breadth of the footing. So actually this is your B. This is the breadth of the footing. And DF is the depth of the footing. And you don't know till now what are these things, this NC, NQ and N gamma. So you need to now understand these three things. Okay, so you see this NC, NQ, N gamma, these three are called bearing capacity factors. What factors I said? Bearing capacity factors. So NC, NQ, N gamma are bearing capacity factors for Terzaghi's equation, and these NC, NQ, N gamma as per Terzaghi's bearing capacity theory will only, please remember this, will only depend on the angle of internal friction of the soil, and some cases only part of it will depend on the Rankine passive earth pressure coefficient. Okay, so Rankine's passive earth pressure and active earth pressure coefficient you will understand when Sayantan sir will explain you about it. But you need to understand at this point that NC, NQ, N gamma in this Terzaghi's bearing capacity equation are called bearing capacity factors, which are basically dimensionless numbers. This is very important. This NC, NQ, N gamma are dimensionless. It hasn't got any unit. They are dimensionless number, and these three factors will depend on angle of internal friction of soil. You can see on the right hand side the Terzaghi's expression is given. You see Terzaghi, while deriving this NC, NQ, N gamma, how this NC, NQ, N gamma has come, that part I have shown you at the right hand side. So you see A, there is NQ, inside the NQ there is a factor A. Now see A is dependent on phi. Now on the other hand you see NQ is dependent on A, so A is dependent on phi, and you see the other terms is also dependent on phi, and pi is a constant term, so there is no problem. So only dependency of NQ is on phi. On the other hand you see next is NC is dependent on NQ, so NQ is dependent on phi. So basically NC will be also completely dependent on phi, and N gamma, if you notice, N gamma is also dependent on phi, this tan phi and this cos square phi, along with another one factor, that is Kp gamma, and this is nothing but Rankine's passive earth pressure coefficient, which will actually come from this. If you remember, yesterday I was telling that zone 3 is zone of Rankine's passive state. So this zone 3 will generate a Rankine's passive earth pressure, and for that Rankine's passive earth pressure coefficient will come, and that Rankine's passive earth pressure coefficient will be included over here. And if you when you will be understanding Rankine's active earth pressure and passive earth pressure coefficient, you will notice there also that Rankine's active earth pressure and passive earth pressure coefficients are also dependent only on phi, or the angle of internal friction of the soil. Thus, you can say that all these three factors, that is NC, NQ, N gamma, all these three factors are dependent on angle of internal friction of soil, and they are dimensionless number. So following this, Terzaghi has found out the values for these. Okay, so values for this NC, NQ, N gamma. So everyone can see this. Terzaghi's bearing capacity theory, bearing capacity factors. So this, see, I have written NC, NQ, N gamma. These are the bearing capacity factors which are non-dimensional and only function of soil friction angle. That means it is only function of angle of internal friction. See, these equations may look complex for deriving this NQ. These equations may look complex while you derive NC, NQ, N gamma, but you see this NC, NQ, N gamma, as I have explained, all will depend only on angle of internal friction of soil. Thus, through the shear strength parameter determination, if you can determine the strength characteristics of soil, that means if you can determine the cohesion of soil and angle of internal friction of soil, you can very easily calculate the bearing capacity of soil, provided you know at which depth the foundation you need to construct and what is the width of foundation. Okay, so if you know the width of foundation, depth of foundation, and you know the shear strength characteristics of the soil, that is C and phi, then you can easily calculate this value of Qu, which is nothing but the ultimate bearing capacity. And this ultimate bearing capacity, as I have said earlier while explaining you the definition about ultimate bearing capacity, you have seen that this ultimate bearing capacity is not only a factor of C and phi, it will also depend on some other factors, and where we have mentioned those factors are shape of the foundation, depth of the foundation, then length of the foundation, breadth of the foundation. Now you can easily observe from this equation that this equation contains a factor C. So it is dependent on shear strength parameter C. The other factors which are dimensionless NC, NQ, N gamma, they are basically dependent on phi, so that those factors are also dependent on shear strength parameter of soil. But other than that, this QU will also depend on the small q and gamma and B. So small q is nothing but the overburden pressure, that is gamma into dF. So that means it will depend on the unit weight of soil, that means it will depend on the property of the soil, as well as it will depend on at what depth you are putting the foundation. As along with that, you also need to know what is the width of the foundation. So if you know all these things, you can very easily calculate what will be the ultimate bearing capacity. Now what Terzaghi has done, putting all the values of phi, he has calculated these values of NC, NQ and N gamma, and considering this NC, NQ, N gamma values, he has prepared a chart, and you see this is the chart you can see over here. So bearing capacity factors are given for every value of phi. So if you put the value of phi over here and then calculate the value of NC, NQ, N gamma, you are going to get the values like this. So see, for every 1 degree the values are calculated, every 1 degree the values are calculated. So you should remember, you need not to remember these values all together. Whenever you will be solving any problem at that time, you will have to refer to this chart. So if you are calculating the bearing capacity using Terzaghi's bearing capacity equation, then you must be using this chart. However, for some cases, for your exam purpose and competitive exam purpose, you must remember one or two things. So first thing you should remember, what are the values of NC, NQ and N gamma while the value of phi is 0. What does it mean when the value of phi is 0? Phi is 0 means soil doesn't possess any kind of internal friction. So that means the soil is purely cohesive soil, right? Soil is purely cohesive soil. If you see, what is the shear strength of soil? Shear strength of soil is equal to is basically tau is equal to C plus sigma tan phi. So when phi is equal to 0, your tan phi is going to be tan 0, that means it will become equal to 0. So if tan 0 is equal to 0, then the shear strength of soil will be equal to C. So when the shear strength parameter of soil, that is the angle of internal friction of soil, is equal to 0, you should remember the value of NC, NQ and N gamma. You see, the value of N gamma in that case will become equal to 0, NQ will be becoming equal to 1 and NC will be becoming equal to 5.70. So if you go back to the Terzaghi's equation, so you see, if you go back to Terzaghi's equation, then you see, then you see QU is equal to CNC. So you see what will happen to this term, 0.5 gamma B N gamma. So N gamma will become equal to 0. So this term will vanish actually, and NQ will be becoming equal to 1. So Terzaghi's ultimate bearing capacity equation, you see, it will become, for phi is equal to 0, it will become 5.7 C plus gamma D, only gamma D, because NQ value is equal to 1. Is there any question on this? Okay. So
স্যার এইখানে কিউটা কি মানে প্রেসারটা?
Q is the overburden pressure. Again and again I am explaining this.
Okay,
this is Q. This is Q.
আর স্যার বিটা?
Q is effective overburden, which is nothing but gamma into D. And the B is nothing but the breadth of the footing. This is your breadth of the footing. B is the breadth of the footing or the width of the footing. Because you see, in Terzaghi's bearing capacity equation, when he is deriving the equation, what is the assumption? He has assumed the footing is a strip footing. That means the ratio of L by B is much greater than 1. I have shown you yesterday, right? That ratio of L by B is much greater than 1. So that is why the problem is being considered as a two-dimensional problem, and only B is coming into the equation when Terzaghi is giving the equation. Okay, So only you see there is no L in the equation. You see initially Terzaghis equation, whatever it is given, see there is no L in this equation. Length of the footing is not there in this equation. Okay. So breadth of the footing is B. Q is nothing but your gamma into D, where gamma is the unit weight of soil and D is the depth of the footing, and C is the cohesion of the soil, and NC, NQ, N gamma, these three are the bearing capacity factors which will depend on the value of angle of internal friction of soil. And second thing is you must remember along with this the bearing capacity factor for phi is equal to 0 at least. So for phi is equal to 0, the bearing capacity factor for NC will be 5.7, NQ will be 1, and N gamma will be equal to 0. This value you should remember. Many competitive exams you will find that for phi is equal to 0, you are asked to find out the value of ultimate bearing capacity or net ultimate bearing capacity or net safe bearing capacity. However, they don't specify any value of NC, NQ, N gamma. So if you do not remember the value of NC, NQ, N gamma, you will not be able to solve the problem. Okay. So at least, not at least, I will say only for phi is equal to 0, you should remember the value of NC, NQ, N gamma. And you see, as you progress from phi is equal to 0 to higher values, you see the values are gradually increasing. So it is an increase of value, okay. So gradually these values will be increasing. Now the question here is, suppose you are given value of NC, NQ, N gamma at 0 degree, or let's say forget about 0 degree, let's say you are given the values at 5 degree, you are given the values of NC, NQ, N gamma at 5 degree. So at 5 degree, let's say the value is 7.34, 1.64, 0.14, and you are given the value of NC, NQ, N gamma at 10 degree. So let's say at 10 degree it is 9.61, 2.69, 0.56. Now let's say the soil for which you want to calculate your bearing capacity, for ultimate bearing capacity, that soil is having angle of internal friction equal to 7 degree. So how do you find it out? Forget about this chart. You are given the value at 5 degree and you are given the value at 10 degree. So your angle of internal friction of soil is 7 degree. So how do you find out the values of NC, NQ, N gamma? Can anyone tell it? Anyone? Have you understood the question? Hello?
Yes, sir.
Have you understood the question what I have asked?
Yes, sir.
Suppose you are given NC, NQ, N gamma value for 5 degree and 10 degree. दो तो वैल्यू दिया है आपको, 5 डिग्री के लिए दे दिया और 10 डिग्री के लिए दे दिया, ठीक है, 6 वैल्यू दे दिया. नाउ योर सॉयल पैरामीटर और द सॉयल shearing strength parameter of phi is 7 degree. So how do you find out the value for 7 degree? You don't have that chart in your hand. So how do you find it out? That is my question. See, for such case, what you will have to do, you will have to linearly interpolate between 5 and 10. You remember linear interpolation? In the numerical analysis course, you may have learnt it, right? And it's very simple. So for 5 degree, it is 7.34. For 10 degree, it is 9.61. So for 5 degree difference, how much is the increase? It is increased by 9.61 minus 7.34. Is it clear? So 9.61 minus 7.34. It is increased from 7.34 to 9.61. For what value? For 5 degree to 10 degree. So for 5 degree increase, there is an increase of 9.61 minus 7.34. So for 1 degree increase, how much it will be? 9.61 minus 7.34 divided by 5. So for 1 degree increase, you have received how much is the increase in value of NC. So once you have got the increase for 1 degree, so from 5 degree to 7 degree, what is the increase in phi? 2 degree. So for 1 degree you have calculated what is the increase, so multiply it by 2, so you will get what is the increase for 2 degree. Then what you will do, you add up this 7.34 with that increased value, and you are going to get the value for 7 degree. So it may not be exactly equal to 8.15, however with this linear interpolation you will be almost nearing to the value. Is it clear now? Have you understood the linear interpolation? This is just basically unitary method, nothing else. You got it? So when you will solve some problem, you will be able to understand it more clearly. Should I proceed? Any question on this linear interpolation? Any question? No. Okay, let's proceed. So you see, next you need to understand another one thing. So can anyone tell me for which kind of footing bearing capacity equation by Terzaghi is valid? You tell now. Anyone? Utkarsh, can you tell? Utkarsh is there or not? Today he hasn't joined. Anyone? Shobhan Sundar?
Sir.
Huh? Shobhan Sundar? No one can tell. Somnath? Somnath, are you listening to me or not listening? Hello? Somnath? Shubhadeep?
Yes, sir.
So are these people are not there in this meeting? They are not listening to this. They are just opened the Google Meet and went away from the front of the screen. That's what is my assumption. Because I am calling anyone, no one is answering. Huh?
No, sir. We are listening.
Where? Shobhan Sundar. I was calling Shobhan Sundar. Shobhan Sundar is there.
Sir, Suraj Anand.
Suraj, you tell Suraj.
सर सर वो प्रीवियस में जो आप बोल रहे थे 7.34 को 3.34 को 2 से मल्टीप्लाई करेंगे तो सर वो 68 आ रहा है तो अप्रॉक्स तो
टेल
सर वो अप्रॉक्स वैल्यू तो 7 पे आ ही नहीं रहा है सर 7 पे आ रहा था 8.60 पर आ रहा है यहाँ पे 8.68 आ रहा है सर
दैट इज व्हाट आई एम सेइंग 8.6 आ रहा है it is becoming more than that. It cannot be.
सर 6.68 आ रहा है सर
6.68 आएगा. Yes. So 6.68. How can it be 6.68?
सर 8.68.
8.68. No, it cannot be. How can it come 8.68? At 7 degree you are saying, na? 7 degree.
Yes, sir.
Yes, that is what I am saying. When these values are given at 5 degree, 10 degree, and then you are interpolating it. Okay. See, these factors cannot be directly linearly interpolated, but in absence of every degree data, you will have to linearly interpolate it, and you may not be getting exactly the value of this 8.15. You may not be getting. You may be getting little bit more than this 8.15. So that doesn't matter. That is what I am saying. So have you understood the concept how to calculate this?
Yes, sir.
You have understood, right? Because if you
Yes,
do
sir.
not understand this, then you will not be able to solve the problems. Because for every 1 degree, phi will not be given in the problem. What you will have to solve? Okay, and if you see Indian Standard Code also, I will show you Indian Standard Code later. In that Indian Standard Code also, values are given jumped by 5 degrees. Not every 1 degree the values are given. Okay, so you will have to do interpolation, because always your value of this thing, angle of internal friction will always not be 5 degree, 10 degree, 15 degree like that, right? It may be 28 degree, it may be 27 degree, 24 degree. So how do you calculate that? So you'll have to understand linear interpolation. So basically, see, it's very simple. I'll show you this. I think many of you haven't understood it properly. That is what I am seeing. CALC, calc. See, can you see this calc calculator? Can you see on the screen?
Yes, sir. Yes, sir.
Yes, sir. See, for 5 degree the value is 7.34. For 10 degree the value is 9.61. So what is the difference in value? 9.61 minus how much? 7.34. Okay, 7.34. Is it okay? So the difference, this difference is coming because of what? This difference is coming because of how much value? 10 minus 5, right? 10 minus 5 degrees. So 5 degrees difference. For 5 degrees difference, the value of the difference in value of NC is 2.27. So for 1 degree, unitary method I am telling. So for 1 degree difference, how much will be the value difference? Divided by 5. So it will be 0.454. Is it clear now? For 1 degree difference, you have difference in 0.454. Now you are at 5. So for 5 it is 7.34. If you want to calculate it for 8 degree, or if you want to calculate for 7 degree. So if you want to calculate, let's say for 8 degree. So for 8 degree from 5, how many numbers you will have to go? 3 degrees. So you will have to multiply. For 1 degree difference, there is a value change of 0.54454. So for 3 degrees change, how much will be the difference? For 3 degree value change, the difference in value will be 1.362. So this is actually the difference in value. Now this 1.362, if you add up with the value which you have got at 5 degree, that is, if you add up 7.34 to this, then what you will get? You will get 8.702. So you see, for 8 degree, the original value is 8.60. From your interpolation calculation, you are getting 8.702. Am I able to clear this concept to you now? Is
yes,
it clear?
sir. Now it is clear.
Yes. So this is how the interpolation needs to be done. Okay. So for every bearing capacity factor value, you will have to interpolate like this. Are you getting? Okay. So now my another one question was there. Who will answer it? That this Terzaghi's bearing capacity factor, this formula whatever we have shown, we have discussed till now, that Q is equal to QU is equal to CNC plus QNQ or gamma DNQ plus 0.5 gamma BN gamma. In which case this formula is valid? You tell. Where you can apply this formula? Anyone? Bolo?
Strip footing.
Yes, it will be applied for strip footing. You understood? That means clearly that the footing where the L by B ratio is much more than 1, right? For that case only this formula is applicable. So you cannot apply this formula for rectangular footing. You cannot apply this formula for square footing. You cannot apply this formula for circular footing. Are you getting? So Terzaghi's bearing capacity formula, which Terzaghi has given directly initially, that is only valid for strip footing. And another thing, any other thing, and it is valid for a shallow foundation. Okay. Now you see, if you want to find out the values for rectangular footing, square footing, circular footing, then are there different formulas? Are there different formulas? Can't you use Terzaghi's formula? So that is the question now. So can you use this basic Terzaghi's formula which Terzaghi has given for shallow rough foundation and for a strip footing, can it be applied for rectangular footing, circular footing, square footing? So that is the point of concern now. So let us see how can we apply this formula for other footings. So let us go to the next slide, and you see the next slide shows it. Okay, so you see this is what I am repeatedly telling you, that remember, you must remember that Terzaghi's bearing capacity theory, it is valid for a rough strip footing. It is valid for a rough strip footing, and you have missed another one point, and also I think I have also missed it to tell you now that this formula is derived assuming the soil is failing by general shear failure. Okay, so it is valid for a strip footing and it is valid for general shear failure. So you must understand one point here, that other than strip footing, if you want to use this formula, you will have to do it some other way. And also you should understand, if the soil is necessarily not failing by general shear failure, in such case you will have to remodify your formulation and then use it. That means if your foundation instead of general shear failure is failing by, let us say, local shear failure, in such case the Terzaghi's formulation will change. Have you understood it? Okay. Next. So you see, next I have shown you that what Terzaghi has said, that however it is valid for strip footing and general shear failure. However, you see this same bearing capacity theory, whatever Terzaghi has given, the same bearing capacity theory you can apply. You can apply for footing with different shapes. That means you can apply it for circular footing, square footing, rectangular footing. So to apply it for different types of footing, what Terzaghi has done, Terzaghi's equation needs to be modified, and the bearing capacity factors, that means that NC, NQ, N gamma, these three factors need to be multiplied with a factor called shape factor. Okay, so the bearing capacity factors can be multiplied with a factor called shape factor, and while multiplying it with the shape factor, you can easily modify this ultimate bearing capacity equation for such kind of footing. That means if you want to find out for a circular footing, then you multiply the shape factor of the circular footing in this equation with NC, NQ, N gamma. And so in general, what will happen, for different shapes of footing, Terzaghi's equation thus will become, and it will take a form like this. What is the difference? Can you observe the difference? What is the difference? Can you observe? The difference, you see, in the earlier formula we have said Q equal to CNC, this SC was not there. So what is this SC? SC is the shape factor which needs to be multiplied with this non-dimensional factor NC. Then the next part, you see, there is another one shape factor coming, that is SQ, which needs to be multiplied with the non-dimensional factor NQ, and there is another one factor S gamma, which needs to be multiplied with the non-dimensional factor N gamma. Okay. Now you see, depending on this type, depending on the type of footing, Terzaghi has specified from his experimental calculations the values of these shape factors. So have you understood it? So if it is a strip footing, then this shape factor values, you see, ideally will be becoming equal to 1, because if you see, if you put the type of footing is strip, then your SC value, if you put back here 1, SQ value if you put back 1, S gamma value if you put back here 1, then you see your equation exactly becoming equal to the previous equation, that is, it will become equal to CNC, QNQ plus 0.5 gamma B N gamma. That means for a strip footing, these shape factor values are 1. Now for square footing, circular footing and rectangular footing, Terzaghi has given the values and specified from his experimentation the values for square footing, where the shape factor for square footing SC will be having a value of 1.2. Exactly the same value circular footing will be also having, that is 1.2. You see the value of SQ is always 1 in case of Terzaghi's formulation. If you want to calculate for square footing or circular footing or rectangular footing or strip footing, every case you see the value of SQ is going to be 1. On the other hand, you see the value of S gamma is going to be 0.8 for square footing and 0.6 for circular footing. Okay. Now you see for a rectangular footing, when you are doing, you see for rectangular footing, if a rectangular footing becomes a square footing, what will happen? B will become equal to L. So when the B is becoming equal to L or L is becoming equal to B, so what will happen? L by B is going to be 1. So it is going to be 1 plus 0.2 is equal to 1.2. So exactly it is becoming giving the square footing value. So you see for a rectangular footing, the value of this shape factor for SC will be 1 plus 0.2 B upon L, and for value of S gamma for rectangular footing will be 1 minus 0.2 B upon L, and for circular footing this S gamma value is going to be 0.6. So you will have to remember these values of these shape factors as per Terzaghi's equation. Is it clear? You need to remember these values of SC, SQ and S gamma. If you cannot remember these values of SC, SQ and S gamma, then you will not be able to calculate the values of ultimate bearing capacity for the foundations like circular footing, square footing and rectangular footing. And you see the values are very simple to remember. For strip footing they will be always 1. For square footing, if you remember the rectangular footing value, that is 1 plus 0.2 B by L and 1 minus 0.2 B by L for SQ and S gamma, you can easily go back to the square footing, because 1 plus 0.2 B by L, if you replace B is equal to L, then it will become B, and L if it is becoming equal, then it will become a square footing. So the value of SC will become 1.2, and for value of S gamma, in that case you see 1 minus 0.2 B by L. So when B is equal to L, it will become B by L will become equal to 1. So your S gamma value will become equal to 0.8, which is nothing but the value for square footing. Only thing you see the difference is the value of S gamma for circular footing, which is given as 0.6 by Terzaghi. So is it clear? Have you understood it?
Yes, sir.
Yes.
Yes, sir.
So let us go to the next one. Okay.
Sir, what is shape factor, sir?
A shape factor, that is what I am saying. Shape factor means, see, Terzaghi has given the equation for strip footing. Now depending on the shape of the footing, the bearing capacity value will change, right? So depending on the shape of the footing means length and breadth of the footing. So the shape factor is a factor which will depend on the shape of the footing. So one for the depending on the shape of the footing, circular footing will be different, square footing will be different, rectangular footing will be different. So their values for ultimate bearing capacity will differ by some amount, and that will be taken care by these values of shape factors. Okay. Let us go to the next one. This is very important. So am I going fast or it is okay? The speed is okay?
Sir, it's okay.
Okay, very good. So you see, today we'll just start with this discussion. This one is little confusing, and sometimes you get confused for this. I was telling you that that bearing capacity equation will be also getting affected by the effect of water table. in it, right, water table in it. So where the footing is situated and where is the at what depth the footing is situated and what is the location of water table, depending on that your bearing capacity equations are again going to modify. Okay, so you please try to understand what is the effect of water table on bearing capacity. Very important concept, very important concept. Lot of questions come in competitive exam, GATE examination, Indian services examination. It is a very simple concept. If you understand the diagram properly, the diagram whatever I have given here, if you understand that diagram properly, you should be easily understanding how to calculate the value for ultimate bearing capacity when water table is affecting the foundation. Okay, now you see, basically you see, if the soil is purely cohesive soil, when the soil is a purely cohesive soil, that means there is no phi inside the soil. When there is no phi inside the soil, there is no angle of internal friction. The soil is purely clayey kind of soil. In that case, the effect of water table, the undrained shear strength parameter, you will have to use the undrained shear strength parameter. So undrained shear strength parameter, if you remember, in your triaxial testing, you have observed different kinds of test: unconsolidated undrained, consolidated undrained. Do you remember UCU, this kind of tests? For triaxial test, when you have studied in your 4th semester for shearing strength determination, triaxial testing. Okay, so if you haven't studied it, you just go back and refresh. Okay, so you will notice, if you go through the triaxial testing, in that triaxial testing of soil, you will able to notice how to find out the undrained shear strength of soil. Okay, so undrained shear strength of soil, when you will be when the undrained cohesion if you use, then for the purely cohesive soil, if instead of C, if you just use the undrained shear strength parameter, that is Cu, then you can easily determine the bearing capacity affected by the water table. So instead of normal cohesion or general cohesion value, whatever you are getting, instead of that, from the laboratory testing, from the triaxial laboratory testing, you need to determine what is the undrained cohesion of soil, and from that undrained cohesion, you should be able to calculate the value of Qu, that is the ultimate bearing capacity. On the other hand, if the soil is a free draining soil means soil is only having phi, that means it has having very good amount of permeability, or the soil is a mix of cohesive and non-cohesive soil. That means when the soil is a mixed mode soil, that means it is a C-phi kind of soil. So it's a mixture of sand and clay. Then due to the effect of water table, the bearing capacity factors you need to use, those must consider the effective stress parameters. And effective stress parameter means, instead of the normal bulk unit weight of soil, you need to use the effective unit weight of the soil. And for phi, and also the unit weight of the soil needs to be changed according to the location of the water table. So basically what you will have to do, you will have to use the effective stress parameter. That means you will have to use phi, considering the effective stress parameter. Okay, so effective stress, you remember what is effective stress? So from the sigma, from the normal stress, if you subtract the value of the pore pressure, that is U, that is sigma minus U, is going to give you the effective stress. So depending on the effective stress, whatever is the value of phi you are obtaining, that parameter you need to use for calculation of ultimate bearing capacity. And on the other hand, you will also have to use the unit weight of the soil, which needs to be changed according to the location of the soil. That means if the water table is located somewhere, the soil is above that water table, you just use the bulk unit weight of soil. If the soil is totally submerged inside the soil, you use the submerged unit weight of soil. If the soil is saturated, then you use the saturated unit of weight of soil, which you have learnt in your soil mechanics very basic initial learning, where you have seen how to calculate the bulk unit weight of soil, saturated unit, gamma sat, gamma bulk, right, these kind of things, and gamma and gamma submerged, gamma sub, all these things you know already. So depending upon the location of the water table, you need to find out the different values of your unit weight, and accordingly you should use those values inside your bearing capacity equation. Because you see, the bearing capacity equation consists two values, Q and gamma. So what is Q? Q is also consisting a term of gamma. So Q is basically gamma D. So accordingly you will have to use the effective value of gamma. That means what is the exact value of gamma depending on the presence of water table. So to take into effect of all these things together, to take into the effect of the unit weight of soil, to take into the effect of phi of soil together inside this calculation of water table, a simplified process you can develop. Okay? So that simplified process is now being explained, and this simplified process is actually being also adopted by Indian Standard Code IS 6403. So Indian Standard Code for calculation of bearing capacity of shallow foundation is IS 6403. I have also shared with you IS 6403 along with this presentation. So you please also have a look at Indian Standard Code IS 6403. I will take up that code just after 1 or 2 classes, and we will explain about the Indian Standard Code provisions also. Okay? Now you see, to consider the effect of water table, first thing you need to understand this diagram. Please understand, try to understand this diagram very clearly, because these arrows whatever I have given, these arrows are very important. These arrows are very important, and whatever the values are written, these values are also very important, because when I will be using these values in this formula, you will have to use these values properly, because these are now written in terms of some alphabetical term, but actually in actual case you will have to put the numerical values. So in numerical values, how to obtain, you need to understand very clearly. So let us say there is a footing, this one is a footing. So this is your footing, and this footing is having width of B. Can you see, this is the width of B, and the footing is lying at a depth of df. So from the ground level, the depth of the footing is df. Okay, the depth of the footing is df. Okay, now you see this triangle, small triangle, and these dotted lines are actually showing the presence of water table on the ground. Presence of water table on the ground. Okay, so you see, it is being observed by Terzaghi that the limit of influence of the water table will not be there beyond the depth B, beyond the depth B from the depth of footing. That means you see, depth of footing is df, from ground level to here the footing depth is df, and after that up to a depth of B, and what is this B? B is nothing but your width of the footing. That means up to a depth of B, there will not be beyond this depth of B, there will not be any effect of water table. That means if any line passes through this and if the water table is over here, that means water table, if it is remaining at a depth below the B amount of the depth of the footing, in that case the effect of water table will not be present in case of calculation of ultimate bearing capacity. So, limit of influence of water table will be extending only up to depth B. Beyond this depth B, and depth B means what? Depth B is nothing but the width of the footing, and depth B is from the depth of the footing, up to the depth B. That means from the ground level, if you see at a depth below df plus B, there will not be any effect of water table on bearing capacity, but the water table is going to affect your bearing capacity when it will be just crossing this limit of influence. It will be crossing this limit of influence. Now let us assume, let's say in the first case, let's say this is where the water table is present. Let's say बरसात का शुरुआत है, rainy season has just started. Before the rainy season, water table was not there. Water table was somewhere here. Okay, water table was somewhere here. So there was no influence. So rainy season has started. Water table has started rising. It has touched this limit of influence, and it has got risen up, and it has reached here. Let's say at some date the water table is having its presence over here. Okay, now you should understand it very clearly. So see, this water table presence is here, that means it is at a depth. You please notice the notation dw dash. Here I am writing dw dash. So this water table is being located at a distance or at a depth dw dash from the base of the footing. Below the base of the footing at a depth dw dash, this water table is present. So if the water table is present over here, then what will happen? So you see, if the water table is present over here, then you see the effect of water table will be only going for the soil below the footing level, because water table hasn't crossed the base of the footing, water table hasn't reached this area. So it will not going to affect the soil above the foundation. So in that case, you will have to only consider the effect of water table up to this depth dw dash. Okay, now you see this water table, let's say gradually increases. More rain, rainy season has increased, more rain. So what will happen? Finally you see the water table has increased, and it has reached some level like this. So you see, now the water table has reached a level which is above the base of the footing, Now you see the water table, the location of water table is basically at a depth dw from the ground level. You understand this difference? So here it is dw is being used to show the presence of water table from the ground level, whereas dw dash is being shown to see the presence of water table below the base of the footing. Okay, now you see what does the water table will do actually. The effect of water table, you see, the effect of water table will be to reduce the unit weight of soil, because if you remember, whenever the soil is saturated, whenever the soil is submerged, then what happens? For the submerged unit weight, you just subtract the 9.81 value from the soil unit weight. So submerged unit weight is almost half of your saturated unit weight. So that consideration is being in a simplified way taken for water table calculation formulation. And for that formulation, you see there are two factors being determined. One is the factor RW1 and the second factor is RW2. Now you see this RW1 factor and RW2 factor, they are the two factor. You see this RW1 factor is being taken for the portion of the footing which is above the base of the footing, and you see this RW1 factor is given as 0.5 multiplied by 1 plus dW upon dF. Now what is dW? dW is the depth of water table from the ground level, and dF is the depth of footing from the ground level. On the other hand, if you see this RW2 factor, it is also exactly equal to 0.5 into 1 plus. You see what is the change? The change you see here, it is we are considering now from the below of the base of the footing, and from the bottom of the base of the footing, you see up to the depth b, the limit of influence is existing. Okay, so limit of influence is existing. So up to the depth b, when it is being existing, then RW2 will be becoming equal to 0.5 into 1 plus dW dash by b. See, you should very carefully notice these two equations. See, RW1, when we are saying it is dW upon dF, little bit larger I do, dW upon dF, whereas you see when you are taking RW2 factor, that is 1 plus dW dash upon b. So you see when we are taking these two factors of RW1 and RW2, you notice one thing. So what is this RW1 and RW2 are doing? What are these RW1 and RW2 are doing? See, these RW1 and RW2, effectively you see it is reducing the value of gamma. Okay. Now I just take a simple example. Let's say when the water table is just present beyond this limit of influence, then what will happen? So you see, when this is present beyond this limit of influence, then what will be the value of your dW? Can anyone tell? Anyone? No one? Hello? Are you listening?
Yes, sir.
So can you tell? See, when what I am asking, let's say just the water table is at this limit of influence, just think about it. So what will be, for if you come to RW2 factor, what will be the value of dW dash? Tell, anyone tell? When
Sir,
dW dash will be equal to B, right?
Yes, sir.
dW dash
Yes, sir.
will be equal to B. When this it is at limit of influence, then what will be the value of dW dash? B. So it will be B. So B by B is equal to what? 1. So 1
Sir,
plus
1
1 is what? 2. Correct? 2 multiplied by 0.5 is what? 1.
1.
So RW2 is becoming 1. So here RW2 will become 1. And that is what we are saying, that there is no influence of water table when it is beyond the limit of influence. Are you getting? This is so simple.
Yes, sir.
Okay? Is it clear?
Okay, sir. Yes, sir.
Now you see the RW1 factor. So RW1 factor is being considered for up to the depth of the footing, So you see RW1 factor, when it is taken up to the depth of the footing. So you see when this water table is just at the base of the footing, then what is be the value of dW?
The
This
D1,
water-
DF, sir.
DF.
Yes, absolutely correct. So when it is just at the base of the footing, then the value of dW will be dF. So it will be dF by dF. So df by df is equal to 1. So 1 plus 1 2. 2 multiplied by 0.5 is how much? Bolo. 2 multiplied by
So
0.5 is
1.
So RW1 will become how much? 1. It will be 1 or more than 1? 1. Is it clear?
Yes.
Yes, sir.
So that
Yes, sir.
means it is, when it is becoming 1, then what will happen? There is no impact on, see this, when RW is equal to 1 and RW2 is equal to 1, then you see exactly the Terzaghi's bearing capacity equation you are again getting back. CNC plus QNQ plus 0.5 gamma BN gamma, isn't it? You are getting back? So
Yes, sir.
what is
Yes, sir.
actually RW1 RW2 doing? These RW and RW2 factors are basically reducing the unit weight of the soil considering a linear interpolation mechanism. Considering it that the submerged unit weight of soil will be almost or exactly equal to the half of the saturated unit weight of the soil. Considering this assumption, these two equations are being formulated. Have you got it now? So considering this, we will be understanding more cases in the next class, because this part is I have seen the students get very confused about this part, but there is nothing to get confused about this. Okay, so you should be very carefully understanding this diagram. So dw and dw dash, if you understand, and whenever a problem is given, if you understand, if you put your values according to this dw, dw dash, df and b, there is no need to think about the problem. Automatically the solution will come up. Okay, so please go through this slide very carefully and try to understand it from your own perspective. Then we will be explaining more cases about it. Okay, so I think we stop here today, almost 1 hour. Okay,
Yes.
so there are more people, and now it is 18 people. 22 people have come, 4 have left.
Sir, RW1 RW2 টা স্যার ইন্ডিকেট কি করছে আমাকে বলবেন?
RW1 and RW2 are the water table factors. So because
Water
of
table.
water table factors, because of the presence of water table, inside the soil, the bearing capacity will be getting impacted. Okay, so how much the ultimate bearing capacity will be getting impacted? Based on these two factors, this RW1 and RW2, one should be able to find out the value of the ultimate bearing capacity. Is it clear?
सर
Yes, sir.
RW1 RW2 एक साथ तो 1 नहीं हो सकते ना?
RW2 and RW1 एक साथ 1 नहीं हो सकता है. It will be, see, when this is beyond the limit of influence, when it is beyond the limit of influence, what will happen? When it is beyond the limit of influence, then always RW1 and RW2 will become equal to 1. If it is coming within the limit of influence, then only you need to be worried about. So you see, that is what I have shown you, that when just the water table is coming over here, when the water table is just coming at the limit of influence, at that time what will happen? This RW2 factor will become equal to 1 and RW1 factor will be obviously becoming 1, because your water table, this DW factor will be much greater than this DF. In that case, what will happen? This DW will be much greater than this DF, and if DW is much greater than DF, this RW1 factor will be having value of more than 1, which it cannot be. So this factor will be only used when the water table is within this limit of influence. Only in those cases you will have to use it, and that is why the RW1 and RW2 factors are separately calculated. You see, that is why I have taken two different values, DW dash and DW. Separate values are being used. So when the water table is over here, then you see on the above part there will not be any effect of water table. So automatically RW1 will be becoming equal to 1. How does the water table going to affect RW1? RW1 is not going to affect water table, because we have bifurcated this foundation into 2 zones, one up to this DF and one up to this B. right? So two zones we have separated, and on the upper zone, for the upper zone up to the depth of the footing, we have taken the value of Rw1, and below the depth df up to the breadth b, up to the depth of breadth b, we have taken the value of Rw2. So when the water table, let's say, is present over here, only Rw2 factor will be getting into consideration. Rw1 in that case will be always equal to 1. Is it clear now?
Sir.
Okay.
Yes, sir.
Okay. Thank you. So you go through this. When we will be solving some problem, you will be understanding it more clearly. Okay. But
Okay.
theory understanding is very important. Other than that, you will not be able to address the problems. Okay. So I think thank you very much. So next week again we will see and go further. Okay. So we will take 1 or 2 problem in the next week initially, and then again we will discuss about the water tables. Okay. Okay. Thank you very much. Okay. Thank you.
Thank you, sir.
Thank you.
Bye.
Bye.